So up to here we have completed the thermocouples. What we have completed in this class? We have completed in this class first is what is thermocouple definition and effect of thermocouples like Seebeck effect, Seebeck effect, filter effect, Thomson effect, दूसरा construction based classification of the thermocouple, grounded, ungrounded, exposed, and the working principle of thermocouple we have seen, and advantages, disadvantages we have seen on thermocouples. And next we will discuss the thermocouple type of thermocouple. This is and this is the general thermocouple equations. E बराबर a into delta theta plus b into delta theta square. This is the standard form. Delta theta is temperature differences among the hot junction as well as reference junction or cold junction. A, B are the constant, accuracy, advantage, high accuracy, thermal reaction fast, some advantage and disadvantage applications we have seen. Right now we will discuss about the classification type of thermocouple, because there are so many type of thermocouple that we have divided them based on their classifications. Suppose that the thermocouples, this tables we have drawn here, we can see this table. First type, in this table we will see the type of thermocouples. दूसरा, the combination of metals and materials that's used, and second and third column we will see the temperature ranges of each particular first type. We will talk about the type B type thermocouple. So, B type thermocouple generally use platinum 30%, 30 platinum 30%, oblique platinum 6%, rhodium 30% platinum rhodium. That's called B type. This range is 170 to 1700, approximated 1400 to 1700 degrees Celsius, the range of B thermocouple. Third is a E thermocouple. The used material is a nickel, chromium, constantan. This temperature range is 0 to 870 degrees Celsius. This is the E type thermocouple. Next we will see the J type, iron constantan. One is iron, another is constantan metal. The temperature range is 700, 0 degree Celsius to 760. Next is nickel, chromium, aluminum. Generally use 0 to 1200, 1250 temperature range is this. And next is N type. Now nicrocell, nacelle, this used to 1260 there. Next is R type, platinum 13%, rhodium remaining, 30% rhodium, 87%. This is the R type, 870, 840. Next is the S type, platinum 10%, 90% rhodium. So this is the S type. T type, copper constant in T type, minus 59 to 370 degree. So negative temperature we can see. This is the, and these are the importance which I am taking. This is the important to use material copper constant, temperature minus 60 to 370. Range is very low, but it can be used for negative temperature also. Second is generally they ask about the R type. Platinum 90%, platinum rhodium, or platinum is 87%. This temperature at 870 to 15. Next is the K pipe. This is generally very used in industries type. This is nickel chromium and aluminum chromium, temperature and up to 60. This is important. And this is the next J type. This is also important. iron constant that use 0 to 76 degree. And we will see each and every thermocouple in detail. First, B-type thermocouple. We should talk about the B-type thermocouple. B-type thermocouple can be used up to 1600 degrees Celsius. Temperature range is too much high, up to 16. They have low electrical, but it's out. This is not generally used because their electrical output is very low. Therefore, they are rarely used. That's why this is not much important. They are rarely used below the 600 degrees Celsius. Fact that they are virtually negligible up to 50 degrees. Therefore, cold junction compressor not usually required with. That's why here no compensation they will not required here. Next, we will see the E-type thermocouple. This is the important thermocouple that generally they will ask exam this thermocouple. This is the E-type thermocouple. This is the important E and K type thermocouple and R type thermocouple. Three type of thermocouple are very important. E-type thermocouple often referred as a chromal constant. Sometimes they will ask the type material that used is the common chromal constant thermocouple. They are regarding more stable. Why they important? They are regarding more stable than K type. So therefore, they often used where higher degree of accuracy is required. Then we can use the where higher degree of accuracy required. Then we can use the E-type thermocouple. Then compared to that's why we are using generally K-type thermocouple industry because in industry we don't need to much accuracy. We need to measure the high range and low cost. That's why K-type thermocouple generally used in industry. Copper constant or nickel constant material. Next is the J-type thermocouple. J-type thermocouple graded rapidly oxidation at atmosphere above the 50. That's why generally it will not use because it oxidizing atmosphere above the 550 say it start to oxidizing. Their maximum continuous operating up to 740. That's why its range is low because below the 550 it start to degrading. That's why deoxidation. Sorry, that's why this thermocouple generally we can use. Next is we can extend this. Though they can be extend up to short duration, like one for short duration for 100 degrees Celsius. Generally, they are not used below the ambient temperatures due to condensation forming wire. So notice material. This material they will ask generally. This material used to constant nickel, and these are the important. Next, we will discuss about the this is the J type. Next, we will discuss about the E type. So E type generally we have discussed the range. So we will discuss short chromal constant material used in thermocouple. This is very important. They are more stable than compared to nickel. We have also studied material that's used in nickel, copper, chromium. Second is a J-type thermocouple. J-type thermocouple degrade rapidly. This is a degrade rapidly. We have discussed this thermocouple also. K-type thermocouple. This is the important thermocouple, and most of industry this thermocouple is used because the cost is low, range is appropriate, and that's why this mainly used. K-type thermocouple most widely used thermocouple in oil and gas industries. This is used oil generally use oil, gas, refinery industry due to their wide range and low cost. Generally, that's why industries like oil, gas, then cake are type are generally used. They are occasionally referred as a chromal aluminum thermocouple. Its name generally you should know chromal. Its the name chromal chromal aluminum thermocouple. This is next is the K type. Low cost, they are generally going referred to this type of chromel alumel thermocouple. This is the very important chromel alumel thermocouple. Second, range about 750. Oxidation lead to drift, so need to recalibration it required. Next is N-type thermocouple. N-type thermocouple. N-type thermocouple can handle higher temperature than K-type. Range is high, but output is very stable. It's not much stable. Output very low than K-type. It offer better repeatability up to 350. Range is 3 repeatability. They may offer advantage over R type, R type, S type, a tenth of the cost. Therefore, the popular alternative R thermocouple. Type R type thermocouple covers similar application as S type, but it improve R type improve the stability and marginal increase in range constantly. R type R tends to use to the reference as S. Next, K-type thermocouple we have discussed already. K-type thermocouple most widely used thermocouple, oil and gas industries, refineries, wide ranges. They are occasionally referred as a chromel aluminum thermocouples. Note that these are about 750-degree oxidation lead to current. Next is a N-type thermocouple we have discussed temperature range, R-type thermocouple, S-type thermocouples. S-type thermocouple continuous use temperature range up to 1400 degrees Celsius. S-type generally 1400. They can be based on short duration execution up to 750. They need protection from the higher temperature atmosphere to prevent the metallic vapor to the tip resulting in reduction EMF. Protecting commonly offered a high purity. Next, T-type thermocouple rarely used a T-type thermocouple. As type general, we have discussed all these thermocouples, and in last class we will discuss this diagram about the we will discuss the range and temperature ranges. Suppose that this is the this is the temperature range in y axis, temperature range in millivolt, and x axis y voltage range in millivolt, x axis temperature in degree Celsius. So different color we have used different of thermocouples. Suppose that E type. This is the E type thermocouple. E type thermocouple is this. This is the more linear up to. Generally, its output is very high, up to 1000 degrees Celsius. It is showing more output. This is the more output is the thousands line. This up to more output is 1000 degree. It is showing approximately 75 millivolt output. It's showing generally 75 millivolt. This is the temperature range is 1000. This is the 1000 ranges. This is the 500 temperature ranges. This then again out again. Then that's why we can see the sensitivity of this output. Linearity, in terms of linearity, which is a more linear. This is the platinum rhodium. Temperature range is high, but that's why when platinum rhodium when be preferred when we need to more high temperature ranges, but output is very low. That means its sensitivity is very low. How the sensitivity will decide as per our change in output. Change in output means millivolt. Suppose that this is the change in output. This is the 28 volt. Suppose the 28 volt change in 28 volt millivolt divided by 1500. So its sensitivity is very low. Its sensitivity is very low. That's why when we need to high temperature, in this case we can use the platinum when low sensitivity is required. Similarly, n-type material, this is the, and this also non-linear, it's so more non-linear behavior, non-linear behavior, non-linear behavior. It's so more non-linear behavior. Again, this is the n-type. Similarly, n-type we can see, suppose that this is the 45, this is the suppose the 45 millivolt sensitivity. We can calculate sensitivity for n-type. Suppose sensitivity is how do we calculate sensitivity? S equal to, this is the so this is 745 millivolt divided by a 1500 1200. So this sensitivity improved then compared to this type, N type. Then the next is a K type. K type sensitivity more improved, and K type is a more linear. Generally, K type are more linear. That's why the cost is low. That's why it used a temperature range up to 1000, more than 1200 degrees centigrade. So this type of thermocouple, generally we can use the industries because cost is low and output is very linear. Second is a J type semiconductor. This is the most stable. J, J type semiconductor, since its sensitivity increases, but then compared to R type, but its non-linearity is going to increase, but sensitivity, but it is it is just output are more stable. Temperature range is generally more than approximately 1200 1240. Its sensitivity are more compared to platinum ruthenium K type, and but it non-linear than compared to S R type. Next is a E type. E type sensitivity are very highest sensitivity. When we require highest sensitivity, then we can use the E type thermocouple. Suppose this is the 75 millivolt divided by how much? 80. So its temperature range up to 1000 degree E type, and voltage range is 75 millivolt. So that's why its sensitivity must be high, but it also increase the non-linear behavior. That's based on the application. So we will decide which thermocouple we can use. This is the next is a T type thermocouple. This temperature range is very low. This is temperature. This is thermocouple. This temperature range is very low. For low temperature ranges, but it can be the negative ranges also. We have discussed it, -50 to 400 approximate degree centigrade. So this we can, that's why we can use this negative. That's the beauty of this temperature T type. So different type of thermocouples we have discussed here. E type, G type, what we have discussed up to here, we can see in short type of thermocouple, different type of thermocouples. Yes, we can see first in table. So in table we can see B type platinum 30%, platinum rhodium 6%. They can be used the B type, and remaining this is E type chromal constant can use temperature range up to 800. This important. This is important example. Important three this and this four are the important of exam point of view. That's why R J type Rn constant use 760 degree temperature ranges. They use the J type Rn constant, K type nickel, chromium, aluminum. That's 1200 to 1260 we can use, and Remaining is R type, platinum 30%, rhodium at 87%. That's why more temperature ranges we can use this 800 degree to 400 450 degree Celsius. E type we can use nickel chromium a constantan, chromal constant, nickel chromium oblique constantan 800 870 800 approximately 8 to 900 temperature ranges we can use. So different type of thermocouple we will discuss. We have discussed. In next class we will discuss. You just be going